Alright, well, I hate doing this, but we're going to have to go in here and poke around and measure voltages. Possible bad cap right here, maybe. I'm going to check all these voltages here. I really don't want to. I think these are DC voltages too. They're bad freaking news. It's possible that that thing could be bad. We're plugged in right now. That is a protection unit right here. I don't know if it's just on receive or whatever. So this is all, this will shock you right here. Ask me how I know. This is why I don't want to work on these kind of radios anymore. This capacitor right here could be bad. That is the coupling capacitor. I honestly don't know how to test it. You see that? It's kind of crusty. I mean, I'd have to discharge everything and remove it out of there. But that'll be the next thing, I think. If that thing is bad, everything else could be working just fine. And that drives the tubes. So we see the red wire comes in from here. See right here? That comes right off of there, guys. So there's another one here too, I think, that might be in line, that mica one there. And then there's that. I don't know. There's some schmutz on here. So we gotta be really careful not to touch any of this crap. We just want to look for our voltages. So they use a lot less plastic gears in these things compared to those other radios. And then that back there is ceramic. Those are all ceramic. That's the only plastic gear, other than maybe one other one. This is where we made a previous repair before on the bias voltage here. So there's we could check for voltage here at some point too. But for now, we want to address all these. So we're looking at that one. It could be this one. It could be the one on the other side. I want to check this one first, since we're sitting here. And what we need is just scroll up a little bit. And let me see if I can slide this over. So this is our board we're looking at. The only cap on this board is 3,300. And I might have one of those. So if that happens to be bad, which I kind of doubt, that's only 25 volts? Oh, I've definitely got something that'll fit in that spot. There's a couple of other ones in here, but I don't think that they would have anything to do with the rest of it. I don't think we're going to find a problem on that board, but you never know. So let me get my meter out. And I need a clip-on lead. So we're going to be looking for... Okay, let me see what this says here. The power supply is designed to operate when the transceiver is operated. I want to know what these voltages are. Okay, so this says DC in. We have AC 14. And I don't know what these are. They're probably AC voltages. Alright. Okay. Okay, what are we on? We're okay, so the board is mostly labeled. Let me turn that off. So the board is mostly labeled. I actually have a terminal here that says ground. This one here is... I can't look at that one because that's 900. I don't think this meter will go to 900. I don't have a high voltage unit. We turn the radio on, everything's on. Okay. That's 300. 259. And that was 190. Okay, so the 259 is low for the 300, and then this one's 120. It's high, 140. And then here's the zero voltage. Okay. And this is AC 14 volts. Okay. And AC 14 also. Okay. And then you got 12 right here. But it's going to be DC. Okay. Should be 8. Okay, I don't know what this one is. I think 8. Okay. There's another 12. And then 6. That's a heater. AC 12 volt. Okay. Looks like everything is there. Get a couple of other ones here. I can't tell. This is a ground. You know, I'd have to look up one of my meters to see what meter I have will read 900 volts. We do need to know if that's any good. Well, these filter fucking caps look a little shit. The big ones. Okay. E. Oh, that's emitter collector. Okay, I think we've addressed all the voltages on here except the 900. Boy, I really don't know what meter I have that will read 900. Nor do I want to. We got a couple of choices here. This is a newer Harbor Freight meter. It only goes to 250 volts. I have one of the older ones. I think it still works. It's missing the back. But these ones were different. They go to 1,000 volts. And I'd rather blow this up than something else. I've got lots of meters, but I don't know what the specs are on them. I've got a Fluke 16. I don't think it goes high enough. And then I have some vacuum tube voltmeters. So one of those might actually work. So I'm going to grab those. So I'm actually not sure if this one works or not. I've got two of them. This is more of a lab type one. So it's a VVTM, which is vacuum tube voltmeter. There's a couple of 12AX7s or something in it. So we have this is zero adjust. I don't know. Didn't seem to be doing anything. DC, DC plus. So it goes up to 1,500 volts. So you got 1.55, 15, 50, 150, 500, and 1,500. So that should be pretty good to get us in the vicinity of like whatever. And the Harbor Freight one might work, and my ft101zd might work also. The problem is, we've got to go pull this damn thing up on Amazon to look up the specs for the ft101zd. So, let me go do that. Amazon! I'm supposed to be browsing Amazon for deals. Did you know that? Okay, the name of this meter is ft101zd. And it is this one here. They have a really cool one. I can't find it. Okay, one of them reads temperature, and one has the no contact. I think this is the one. What does it say? 18B plus? Okay. And this is a copy of like a Fluke 17, by the way. And it's a really good meter. I highly recommend it, but I don't know. They've got a $39 meter. I don't know if they have that anymore. No, the $37 one. It's like 60 or 20,000 count. It's much more like the actual Fluke one. I'd love to have it, but at $37, I don't really feel like I need it when the other one's 21. But we need to come in here and find out what the limit is on this thing. And I don't think I got any paperwork with it when I bought it. Okay. DC voltage range accuracy 600 millivolts, 6 volts, 1,000 volts. Oh, okay. I think we're good. AC current range. So at 1,000 volts, it's plus or minus 0.8% plus 10. Okay. Capacitance range and accuracy. Okay, so DC voltage range and accuracy 600 millivolts, 6 volt, 1,000 volt. So we're good. We should be able to just come in here and take a look at this. If it smokes, then I will contact them and say, well, what in the hell? All right. And it does that all the time. It drives me nuts. And it's definitely DC, which is nasty. You don't want this. Trust me. Okay. I can't see very good. We need to be... Okay. Jesus. I just don't even like touching this shit. $925 volts. Do you see that, guys? So we've got our voltage. Man, I just get nervous every time messing with that. I should check my VVTM while I'm at it though. Somewhere back here is the rest of the Heath kit. The problem with the Heath kits is they use this stupid thing where I think it's a goofy ass probe. Well, it wouldn't be like a probe, an ass probe. But it sure is a goofy probe, right? Use this as an ass probe. So this thing is the probe for one of these. And I am not going to test 900 volts with this probe. Especially the condition that it's in. This is the ground wire. So this is probably from the 60s, and I think this particular one is maybe from the 80s. What we'll try, I want to see. I need to go for, let's see. We have some voltages in here that would be safe to look at. It's also got like some switch on the end, which I don't really know what it does, to be honest. Okay. So I want to put it on 12 volts. I got nothing. It's possible this thing don't work. The zero adjust finally stops. I don't even know if actually this is the right probe for this thing. It doesn't seem to want to work. Okay, so you get RX. One meg. RX1. I don't know what that actually entails. I thought you're supposed to be like able to adjust this thing. Okay. Okay, this doesn't seem to work. I don't know if this thing's just broken. Okay. So I think we just found ourselves another project, guys. Let me unplug this thing. And we're going to pull out the other Heath kit. You know, there was like 2 of these at the thrift store one day. I forget what I paid for it, like 20 bucks. $24 it says. Now I'm not sure that it doesn't work, to be honest with you. So it could be that they used a different type of plug for that one. So I'm not going to condemn it yet. Now this one here definitely worked at one point. And this is what the cord actually goes to. So, and I found this at the thrift store a long time ago. Not even sure. If what state it was. Oregon, California, Washington, Arizona, I don't even know. think it came from here though. I don't know. And then there was one that I actually had somebody gave me. Okay. This one here I think is a little bit more handy, to be honest with you. You get really poor lighting here. Okay, so we go ohms. 8 ohms. Okay, see it's alright, let me see. It's definitely doing something. And it's possible there's something going on in this probe. Yeah, that quit doing anything. Everything I got is just not working, guys. We should not be here. Okay, let's come in here and measure our 12 volts. Pinned it. Oh, because we're on 1.5. Good Lord. That thing got stuck. Alright, my bad. 12 volts. It reads... Dude, it reads 12.2. Somewhere around there. I don't know, it depends on how you want to read the lines. But yeah. It works. Okay. Jeez. Alright, let's go all the way max. Where's the rubber glove? I need a rubber glove. Oh my god. I don't want to hold this damn thing. Oh my god, I can see the spark going right into that fucker. Okay. DC volts. Let me show you something here. And I'm going to show you why I don't like this. Do you see that spark? Is it showing up on the camera? Okay. So we're on the scale right here. So DC 1, 2, 3, 4, 5, and between the 9 and the 10. So yeah, and so this works. I want something better than this. I don't trust this. I don't know, because it starts, old stuff can get leaky and conductive. So, but that actually works. So I'm happy with that. Yep. This, guys, is why I don't want to work on these kind of things anymore. Okay? I've been shocked a couple of times, and it really ain't no fun. And I won't work on HF amplifiers. Like, I just won't do it. Not with them powered up. Like, if this was an HF amplifier, forget it. If I can't fix it with it being powered off, it ain't getting worked on. I'm not working on a live amplifier. No frickin' way. You know, they got like 3,000 volts on the plate, and you're not going to make it. I guess some people have, but you're going to be, it's going to take a chunk out of you or do something really bad. So, anyway, All our voltages look good here. I don't know about this damn capacitor. I would probably say that could be it. And I don't think I'm going to have anything that's going to work to replace it. I don't know what the value is. It's really hard to tell what it is. It's I do have one similar to that that's marked yaesu. There's a little corrosion on here that kind of concerns me, but other than that, I don't know. The coil looks fine, but if that is in fact the coupling cap, it could be bad. So I would have to power this thing down, drain everything, unsolder it. I do have a meter that'll read it, and it doesn't do ESR, but yeah. So one of the ways I got shocked once before was I had a radio right here. This accessory plug has 900 volts on it, 300 volts, and whatnot. Well, the wires were sticking out of it. They clipped them. They were just sitting out there. It was on a 901. And grabbed that thing, and it lit me up. I don't know, with 900, whatever. But, damn, quit beeping at me. So, there's a bunch of voltage here. There's some voltage on these. There's some voltages down here because you're in the tank circuit. And then, obviously, here. And on that as well. And these don't have anything on them, but anyway, we're going to flip this thing over and we're going to test our other board. Alright, so this was the board. We had 250, 190, 120, and then there's a 12 volt line, ALC, bias. I did not actually, I don't know that I read the bias ones. So if the bias is not there, then yeah, we'd have a problem. This one here, I can't read. They put a mark through it. 160, 180, 210, and 300. They actually don't, for some reason, they're not showing the 900 here. Where is it? I wonder if that was it right there. Or am I looking at the wrong one? I'm looking at the wrong one. Okay. Yeah, we were on this one first. Okay. So AC 14, ground AC 14, 120, 190, 300, 320, DC in 12 volt, AC 12 volt, heater. I can't read these. It looks like it says 8 volt. And a 6 volt, ground, DC something. DC contact. There's a relay in here. Okay, 900 volts. So I don't know what that contact is for. Maybe a transverter. We got 900 volts, and it's definitely there. Ground. In fact, what were we seeing, like 950? So now we're on this board here. Let's just take a little read real quick. When the transceiver is operated, no, we don't care about that. 14 volts AC power is delivered to the secondary winding of the power transformer. Okay. The power amplifier plate voltage of plus 800 volts is supplied from the bridge controlled doubler located on rectifier unit A, consisting of diode D901 and D904. AC 190 volts is rectified, producing 210 for the screen grid supply of the power amplifier tube. The screen grid voltage for the driver tube is obtained by rectifying 250 volts AC at D1001, producing 300 volts. This voltage is dropped to 180 volts by a resistor for delivery to the driver tube screen grid. 120 volts AC from the power transformer secondary winding is rectified in order to obtain negative 140 volts for the driver and final amplifier tube grid bias. We need that. If that's not there, this thing won't work right either. Okay. So here's the bias VR. Oh yeah, if the bias VR on this board went bad too, you know, we could have some problems. So, but I think we're gonna have a problem in this board over here. I don't know if you guys can see the mouse, but yeah, I think that's where we're gonna have a problem. Where's that board? Rectifier A is on the bottom, and rectifier B is on the top. Okay, so, and I believe I have worked on this before and inspected it or something. The caps all look like pretty normal, but that doesn't mean anything. But there's been very few instances where I've literally just found like a bad cap that looked normal. So usually if they look good, they're good. Usually. But these are the ones that are most likely to be bad. So what we're looking for on this board is 250, 190, 120, 12. We need our bias voltages, what we don't know what the hell they're going to be. Are the bias voltages, they're negative DC, I think. Where does it say? Where's the bias voltage? Okay. 190 volts is rectified, providing 210 for screen grid. 120 volts AC power from the transformer secondary winding is rectified by D1003 in order to obtain negative 140 volts for the driver and final amplifier to grid bias. Okay, so if we don't have that, which is quite possible we're missing that, because that's what it's acting like. Okay. We'll leave that up there. Alright. Okay. We'll get the meter down here. Let's see here. Well, we're gonna have to zoom this thing out. I am tired of trying to get this camera to work correctly. Okay. Let's go for negative 100 volts. Is that not DC? Oh, you know, also, it does help if you have your ground part hooked up too. This should be a good place. Or you just go like that. Gosh dang it. I dropped my flashlight and it starts strobing. Okay. Well, that's negative 100, so you get negative 166.9 there. This says 160. Ooh, that's 230 volts. What the frickin' hell? And it seems a little high. And then this says 180. 241. This says 210. 258. And here's 300. 352. I can see the bias ones right here. There's also another one down here. 230. Okay, so that's AC 230. We'll check that. We're on true RMS. 256. And 191. That's the closest one. And I think that's AC 120 right here. $141. And I can't read that one. There's a diode in the way here, which is see what we get. I don't know what that one would be. Okay, it says ground. Okay. Here's one that says ALC. Alright. Key. So these ones also the key and the TX12. We need to check those later on to make sure. Oh, one of these is burnt. That one right there. And what is that? It looks like a 470. So we have a burnt red resistor right here. It's not super crispy or anything, but it's burnt. Okay, so let's go back to DC. And oh no, it's not DC voltage, is it? Wait. Yeah, it is. Okay. You need negative 33 and negative 12 for the bias. Interesting. So I think we have a bias problem. We're supposed to have negative 140 volts. Okay? So, well, let's go take a look at the manual and see what they say. That might be our problem. Alright. So, now, does it bias that voltage when it's keyed up or not? That's the other question. So, let me try really quick to measure that. Well, that's awfully weird. So I moved something here. And I'm now getting 128, negative 128 bias to the actual big tubes. But the other one is reading elsewhere. Still that 34 volts to the 12BY7. Okay, so why is the 12BY7 got the wrong bias? It's really weird. And what I wanted to do was okay. Well, to obtain 140 volts for the driver and the final amplifier tube grid bias. Okay, so, and the bias set is right there on that board. Okay, dangerous voltages are present within the transceiver. Yeah, no kidding. We recommend using a Hewlett-Packard Model 401B with an RF probe. A VVTM. Okay, so we need to figure out the bias. I'm probably gonna have to download the actual service manual. Carrier balance. Okay, here we go. Let's just see what they say. Variable ALC meter adjustment. Okay, rectifier unit. Okay. Bias adjustment. Set the mode switch to USB or LSB and set the mic gain to fully counterclockwise. Place the meter switch in the IC position and set the Vox control to Vox. Adjust the bias control located on the rectifier B unit for a reading of 50 milliamps for 10 watt models. The correct reading is 25 milliamp. Okay, so this is going to be kind of a pain. So they want you to what? Might gain fully clockwise, counterclockwise. That means that you would have no ability to do anything. You put in lower sideband. Meter switch to IC. Set the Vox gain control to Vox. That doesn't make sense. And set the Vox control to Vox. And adjust the bias control located on the rectifier unit for a reading of 50 milliamps. Let me get this coax on here just in case. It's not at 50, but it's not far from it. They're not being very clear about what you're supposed to do here, but what you do is you key the thing up, and by doing Vox, you can do that. We're at like a quarter of the way, or we have another quarter to go. Okay, so weak mind. Magic screwdriver. I have a couple of these screwdrivers will work fine, but I'm looking for the one that's a little easier to use. Oh, Lord. Every time I need something, I cannot find it. I guess I'll have to use this one. All right. All right. Now, let's come in here and see if any of this has changed. 127 volts bias. And negative 34 on the other, but I don't think it's supposed to be negative 34, but I could be wrong. We need to check R6. R6. All right. We need to check for TX 12 volts also. Okay. $7.8. That's not right. That seems a little strange. $8? I don't know. Something's not right here. So we got 10, 10, 10, 10. And then we have another Elna down here. What is that one? 240 volt, another 10. So you get 47s, 22s. I've got a 47. A 47, a 33. So 22, 22, 47, 33, 10 and 10 and 10 and 10. I think they're all... Yeah. So I know I have some of these caps. Okay. So is there any more mention of the bias voltage? And this particular trimmer looks like it's been like modified or changed at one point in time. Okay, let's see if we get any other information on this. All right. Nope. Okay. Okay, so on the Internet Archive, I found the service manual. It's kind of hard to find. I don't like to use Electro Tanya or any of those lib manuals. I don't trust them. Modifications to the rectifier B unit. 318 BFO drift. AF unit capacitor polarity check. Some of these had backwards capacitors, I guess. Maintenance and alignment, fault localization, troubleshooting chart on page 3-37. Okay, so let me flip through this thing here. I have that mic, but mine's called a UD 844. I'm going to shrink that a little bit. I don't know where we're going to be looking at. Alright, so we're on the modification page for rectifier B unit. Let me see, I can't even read it. It says... Wait for modification. I don't even know what the hell that is. PB 1849. I don't see those screws. I don't know what the hell. In order to provide additional protection for the power supply circuitry, several changes were adopted in rectifier B unit. Blah blah blah. The modification procedure, adding a 270 ohm resistor, white and red, white and yellow, yellow, white and green, green. I don't see any of those wires here for that board. That must be the other board. It does look like the other board. I thought B was the one up at the top, though. Yep, I don't know. Yeah. Let's see. Yeah, I don't know. I'm not going to get into all that, that's for sure. Page 318. Good Lord. Oh, what does it say? After lot what? Can't read it. Well, you know, it is so hard to read these damn things sometimes. After lot something 6? Is it equals 6? I don't know. Jeez. Alright, whatever. Rectifier B unit parts layout. Vox modification, counter circuit modification, maintenance and alignment. Let's see. Okay, so they say here, the flow chart. IC okay, but no power output, which would be grid current. I don't know if they mean it's okay, but like, is it okay when you transmit, or it has the correct idle amount? Defective L1, L2, or L9, shorted VC1 or VC2, defective C66. Low bands only, defective C5, C8, defective RL2. That could be. Cold solder joint between band switch and tank coil, defective band switch, defective 6146. Okay, no IC indication. Idling IC okay, but no drive. Okay. So idling IC okay, but no drive. Defective 12BY7. No screen voltage because of defective R1603. C1009. R defective Q105, 106, 104. So there's a bunch of stuff that can be checked here. So let's see. No power out on lowest sideband only. No power out on CW tuned. Defective X504. It does put out power on AM, but nothing on CW. Let's see what else we got here. So that's where we're at here. So I would say I need to figure out what these parts are. But anyway, guys, we'll deal with it tomorrow. Thanks for watching. Maybe you learned something. Maybe you didn't. I don't know. I'm doing this for my own documentation. I'll catch you later.